Hello, and welcome to another edition of the Daily Bolt with your host, Dr. Jeff Tilley. Today's topic, killer asteroids, moving the solar system, and other nonsense. So, Happy New Year to anyone who is tuning in today and has missed the last few podcasts. It's probably the last time I'll wish you Happy New Year 2020. But we're 3 days into the new year, and we already have some nonsense out of the scientific community. What's more sad about this nonsense is that it looks like that researchers were funded to pursue this nonsense, and it's actually been published in a peer-reviewed journal, which I think is going to hasten the series I have coming up with podcasts about things about how science currently operates that don't work so well. And so we'll leave that for another time. Let's just come back to the topic today. And this topic is motivated by the fact that it is possible that a near-Earth object, basically an asteroid, comet is possible, but an asteroid is much more possible, that is significantly large to survive its entry through Earth's atmosphere, strikes the surface, causes considerable damage at minimum. Depending on how large this asteroid is, it could be an extinction event. We have evidence from paleontology that suggests that in the past, a large asteroid may be what have been responsible for the large-scale extinction of the dinosaurs. And now we only have a few species left that can be traced back directly to those creatures from the Jurassic era. Anyway, there is considerable interest about the possibility of another killer asteroid coming in, striking the Earth, basically wiping out most life on the planet, if not all of it, through the changes that could occur depending on where it strikes, in terms of oceans, in terms of landmass, wildfires, putting lots of dust and debris in the air and causing another ice age. There's all sorts of theories that have been proposed as possibilities. We do have certainly records of much smaller asteroids striking the planet. There's a big crater in northern Arizona. There's a large area in Siberia where forests were flattened by the impact of an asteroid. So this is not a non-existent threat. It is a real threat. It is somewhat improbable. However, our detection of near-Earth objects is not perfect. It's pretty good. We knew a week ago that this particular week there would be at least 6 significantly sized asteroids that would pass relatively close to the Earth. Their trajectories were plotted and computed and monitored throughout, even though they did not pass close enough to pose a significant threat. There was one yesterday, and there was one a few days ago. Actually, several few days ago. So this is not a threat that is, again, non-existent. It's a real threat. It could happen. And there are contingency plans in place, and certainly some disaster movies that have been made based on asteroids have elements of what some of these plans might look like. But the fact is, there is always the possibility that something will be big enough and will head straight for the planet, and we won't have another way to deal with it. So that has motivated research on what to do, not just in terms of maybe obliterating the asteroid with a nuclear blast or something else, moving it, changing its trajectory, but now we have this plot which was devised by a physicist from Illinois State University and a German colleague. It's a huge engine. Not onion, engine. It's a huge engine that is supposed to be placed near the sun that will effectively use the sun's energy to move the entire solar system. And This would be done if a near-Earth object, asteroid, or comet, or something else would be detected early enough that we would be able to move the Earth out of the asteroid's trajectory. Also, if supposedly this was designed in the attempt to prevent our solar system from being exposed to a supernova. And we're not super close to any other stars, but it's unknown if a supernova that's relatively close would have a significant impact on the magnetic fields in the solar system. There's been speculation, there's been research on all of that, but on the other hand, the threat of a supernova seems a little bit more far-fetched. So, one option that he proposed was to build some sort of megastructure using materials that apparently haven't even been invented yet, or there's no way of even suggesting how you might acquire them and build this structure that would shift the position of the sun and drag the entire solar system with it, kind of like if you were taking a little ball on a string and twirling it around, and you just move the ball outward, then the string goes outward with it, and it carries everything with it. There's problems about this. The first problem is that it seems to make the assumption that the entire solar system is a singular object that can be moved uniformly. And that doesn't make any sense, because you have the planets going around the sun, all in their own individual orbits. If this engine is only near the sun, yes, the sun has an enormous gravitational field that is what keeps the various planets and other objects in the solar system in orbit in the first place. The problem is, how would you get this to initiate smoothly without at least some initial shock wave that would disrupt the orbits? And once you disrupt the orbit of the planets and their moons, you may cause other inadvertent effects. You'd affect the tides at minimum. You might affect things like the tilt of the Earth on its axis. It might not be a very big change, but you don't need a very big change to be able to make a major impact on many aspects of the planet. There's tons of geophysical research on that. The other more obvious question is, most of the near-Earth object asteroids that threaten Earth come from within our solar system anyway. So you're going to move the solar system, you're going to move those asteroids, and in fact you may disrupt their orbits because they're very small objects, and the reason that they're intersecting the Earth's orbit in the first place instead of staying out in the asteroid belt often relates to small changes in gravity that take them out of their orbit within the asteroid belt and change the orbit on a trajectory that moves it towards the inner planets or outward towards the outer planets, or both. And so it doesn't seem like this is the right solution to the problem, because you're not getting rid of the asteroids in the asteroid belt. Okay, maybe this is a way to move the solar system from a supernova, but how much collateral damage is there going to be in the process? So you might spend an enormous amount of money and time to put such a superstructure together. Granted, this would be likely hundreds of years in the future, because you would need materials that no one knows how to even design. So this is all in the pie-in-the-sky theory approach, and it might not save any more lives than it gets rid of. And so this just seems like a fanciful idea, which would be fine if a scientist had dreamed it up. But in order to spend the effort to actually try to design this type of structure and try to figure out at least some of the problems, even though it doesn't seem like he's figured out all the problems, like getting rid of the asteroids, somebody had to fund this. So somebody in some science agency thought this was a good expense of money. And someone in terms of this guy's peers, the reviewers in the journal Acta Astronautica seem to think this was a worthwhile subject to publish. Maybe. I hope it's gotten some significant critiques in the journal. I have not looked at the journal. Most journals are expensive to subscribe to for individuals, and so I don't subscribe to them. But there's all sorts of bizarre things that get published and get funded in science. Again, that's more a subject for another time. This one in particular does seem like pie in the sky and kind of ridiculous, because until it gets rid of the asteroids, you're not getting rid of the problem. And why would you ever do it? Anyway, I don't have any more to say on this. I'm hoping that this is not a harbinger of what the year is going to look like scientifically, but if it is, we'll get through it. So for today's Daily Bolt, I'm Dr. Jeff Tilley. Have a good afternoon, good evening, good morning, whenever you listen to this, and God bless.